Hello everyone. So this is the second part of the trigonometry. In this video tutorial I'll be covering trigonometric identities. So let's have a look at some trigonometric identities. One of the common trigonometric identity is tan theta is identical to sine theta over cos theta. So it's a ratio of sine theta over cos theta. Then you have sine square theta plus cos square theta identical to 1, which can be rearranged as sine square theta can be rearranged as 1 minus cos square theta, and cos square theta can be rearranged as 1 minus sine square theta. And 1 minus cos square theta can be written as, or you can say factorize as 1 plus cos theta 1 minus cos theta, and same for 1 minus sine square theta can be written as 1 plus sine theta 1 minus sine theta. And we already know that sine of minus theta is equal to minus sine theta, cos of minus theta is equal to cos theta, and tan of a negative angle is minus tan theta. Okay, so let's look at questions. In this question you have to prove that sine a over 1 plus cos a plus 1 plus cos a over sine a is identical to 2 over sine a. So you have to choose a side, and it's very obvious that you'll choose left hand side. Now you can take the LCM, which is 1 plus cos a times sine a, and this would be sine square a plus 1 plus cos a the whole thing square. So sine square a 1 plus cos a the whole thing square can be expanded as 1 plus 2 cos a plus cos square a over 1 plus cos a times sine a. Sine square a plus cos square a is 1. 1 plus 1 plus 2 cos a over 1 plus cos a sine a. And 1 plus 1, 2 plus 2 cos a, if you take 2 common out, you get 1 plus cos a. In the denominator, you have 1 plus cos a times sine a. So as you can observe here, 1 plus cos a and 1 plus cos a would be simplified, and the resulting simplified expression would be 2 over sine a, which is what they had asked. Okay, so this question maybe you have to use the identity. Now what is the identity that you can think of which can replace this 1 minus cos square? See, 1 minus cos square can be factorized as 1 plus cos x, 1 minus cos x, right? And in the denominator you have cos x plus 1, which you can rewrite as 1 plus cos x. And observe that 1 plus cos x and 1 plus cos x would be cancelled out, and you would be left with 1 minus cos x. ये easy, बहुत easy थी. Okay, now in this identity, okay, so this is the advice. Whenever you see tan, try to replace it with sine and cos. So cos a over sine a plus sine a over cos a, and then you simplify this. So the LCM would be sine a cos a, and this would be cos square a plus sine square a. And you very well know now that cos square a plus sine square a is 1. So 1 over sine a cos a. Now you could be asked to solve trigonometric equations which might involve trigonometric identities. So if you are being asked to evaluate sine theta minus cos theta equals to 0, you are being asked to solve for theta within this range of theta, then sine theta is equals to cos theta, and sine theta over cos theta is 1, tan theta is equal to 1. Now the same concept, tan theta is positive, so it's positive in the first and the third quadrant. Find the basic angle. So tan inverse of 1 is 45 degrees. Okay, so tan 45, so your theta is 45, your alpha is 45, basic angle is 45. This is your first angle and this is your second angle. So the angles of theta are 45 degree and 180 plus 45, which is 225 degrees. These are the solutions of theta from 0 to 360. So in this question you have 3 minus 3 cos theta equals to 2 sine square theta. Now you can see that you have two trigonometric ratios, so it's better to convert one of sine square in terms of cos square, because you can use this over here. You can use the identity 3 minus 3 cos theta is equals to 2 sine square, which is 1 minus cos square theta. Okay, so if you simplify this, 3 minus 3 cos theta, 2 cos square theta minus 3 cos theta plus 1 equals to 0. Hence it's a disguised quadratic, And if you try to solve this quadratic equation by factorization, okay, you can, or you can use the quadratic formula. So the values of cos theta would be 1 and 1 over 2. Now in order to find angles from this part, remember that the range is from minus 180 to 180. So cos theta is positive. It's positive in the first quadrant and the fourth quadrant, but no need to take the fourth quadrant. Okay, yeah, but you can mark it over here. So in our case, we have negative angles as well. So let's find the negative angles from 0 to 180, and then 0 to from minus 180 to 0. So the first negative angle is this. Okay, now let's find the basic angle. Cos inverse of 1 is, cos of what is 1? Cos of 0 is 1. So the basic angle is 0. Okay, so what you can do is you can you can correct this diagram, correct the sketch. You know that the basic angle is 0, right? So, and cos theta is positive. So cos theta is positive in the first and the fourth quadrant, and basic angle is 0, which means that this is the line that you are looking at. Now the negative angle, there is no negative angle from here. Okay, so theta is 0, and that's the only answer from here, 0 degrees. Let's look at the second part, where cos theta is equal to half. So cos theta has a positive ratio. Let's find the basic angle from here. Alpha cos inverse of half is 60 degree. So cos theta is positive is in the first and the fourth quadrant. So the first angle, let's look at the negative angles pehle. Pehla negative angle is this, and the other negative angle is this, but this is of no use because it will exceed our range. So the first angle is minus 60 degree. Now let's come to positive angles, which is this angle, which is also 60 degree, because if we cross this angle is greater than 180. Yeah, so in total the values of theta are plus minus 60 degree and 0 degree as well. हाँ जी, तो इस क्वेश्चन में you have to replace cos square, right? So आपकी इक्वेशन हो जाएगी 5 sin theta plus 3, and you replace cos square with 1 minus sin square theta equals to 5. So 5 sin theta plus 3 minus 3 sin square theta equals to 5. Rearrange कर लो, simplify कर लो इसको, and you get this. And the true values of sin theta would be 1. Sin theta is equal to 1, or sin theta is equal to 2 upon 3. Now let's find angles from here. Sin theta equals to 1. Okay, so basic angle would be sin inverse of 1, which is 90 degree. Let's look at the range. It's all positive angles. Now 90 degree and sin theta is positive, so it's positive either in the first or the second quadrant. Okay, if you're okay, now so the first angle of theta would be 90 degree. The other angle is 180 minus 90, which is also 90. So just let's leave it over here. Now about the second part, you will take sine inverse of 2 over 3, and you get alpha as 41.8. Now sin theta is positive in the first and the second quadrant. These are your alpha, meaning the basic angle. So the first angle is this, and the second angle is this. So the first angle would be 41.8 degrees, and the next angle would be 180 minus the answer, which is 138.2. Okay, so in order to summarize this, that all the angles for the solution of this equation would be 41.8, 138.2 and 90 degree. Yeah, okay, in this equation we have multiple angle. So our angle is 2 theta. Okay, so what was the first step? The first step was to alter the range. So 2 theta would be from 0 to 720, and I told you that you can replace it with a. So yeah, a would be from 0 to 720 degree. So I will have to solve this for a now. Again, two different trigonometric equations, which among them would could you replace? Yes, you could replace cos square. So 2 sine A plus 8 times 1 minus sine square A equals to 5. 2 sine A plus 8 minus 8 sine square A equals to 5. Again a disguised quadratic. 8 sine square A minus 2 sine A minus 3 equals to 0, and the two values of sine A would be 3/4 and minus half. So if sine A is 3/4, meaning your sine theta has a positive ratio, and we are looking for angles A from 0 to 720. So this is our first angle. I mean, your angle could have been over here or could have been in the second quadrant. This is your basic angle. Okay, so the basic angle for would be sine inverse of 3/4, which is 48.59. Therefore the first angle for A would be 48.59. The other angle would be 131.41. Alright, now these are just two angles between 0 and 360, but your range clearly says that you need to find the angles of A from 0 to 720. So you add 360 degrees for further angles. So 48.59 plus 360 gives you 408.59 degree, and you add 360 to 131.41 and you get 491.41 degrees. These are all four angles for A. Okay, now if you were to look for the solutions of A from here, from this part, if your sine theta is negative, it's lying in the third and the fourth quadrant. Now let's look at the basic angle. Sine inverse of positive half would be 30 degree. Okay, so we are looking at this angle and this angle. These are the two angles that we are looking at. So the first angle would be since it's in the third quadrant, it would be 180 plus 30, which is 210. The other angle would be 360 minus 30, which is 330. Now these are just the two angles from 0 to 720. You need 0 to 360. You need to go till 720. So in 210 you'll add 360 and you get 570 degree, and you add 360 to 330 and you get 690. Okay, so these are the angles for A from here, and these were the angles of A from here. But we weren't asked to find the angles for A, we had to find the angles for theta. Okay, so we know that 2 theta was equivalent to A. So in order to find theta, we had to divide A by 2. So you have to divide all of these angles by 2. Okay, so let's start by writing all of the angles. The first angle was 48.59. The other angle was 131.41. Then came 210. Then 330. Then 408.59. 491.41 and 570 and 690 degree. Now for theta you need to half them. 48.59 divided by 2, 24.3, correct to one decimal place. 131.41 divided by 2, which is 65.7. 210 divided by 2, which is 105 degrees. 330 divided by 2, which is 165 degrees. And similarly for the rest of the angles, I'll just quickly divide it. So these are all the angles of theta, and notice that all these angles are within the original range. Okay guys, thank you for watching this video.